Welcome to Better Health Faster. Today we're looking at groundbreaking research that reveals how everyday chemicals may be quietly harming the trillions of bacteria that live inside your gut. This isn't about exotic toxins or industrial accidents. It's about the pesticides on produce, the flame retardants in furniture, and chemicals in products you encounter every single day. A major study from Cambridge University has identified specific chemicals that damage beneficial gut bacteria. And more importantly, there are practical steps you can take to protect yourself. Your gut microbiome is home to roughly 4,500 different types of bacteria that help keep your body functioning properly. These microbes aren't just passengers. They influence your digestion, your immune system, your metabolism, and according to emerging research, even your mental health. But what happens when the chemicals in our modern environment start attacking these essential bacteria without us even knowing? That's exactly what researchers set out to discover. And their findings reveal a hidden threat that most of us have never considered. For decades, scientists have understood that antibiotics can disrupt the gut microbiome. That's why doctors often recommend probiotics after a course of antibiotics. But antibiotics are designed to kill bacteria. What about the thousands of other chemicals we're exposed to daily that weren't designed with bacteria in mind at all? Modern life exposes us to synthetic chemicals through food, water, household products, and the environment. Many of these chemicals have been tested for human toxicity. But here's the gap in safety testing. Until now, few researchers had systematically examined how these chemicals affect the bacteria living inside us. Your gut bacteria perform essential functions that you can't do yourself. They break down fiber, produce vitamins, train your immune system, and form a barrier against harmful pathogens. When this delicate system is disrupted, research has linked it to digestive issues, obesity, weakened immune function, and effects on mental health. So understanding what might be disrupting this system is critically important. That's exactly what a team at Cambridge University set out to investigate. Their study, published in January 2026 in the journal Nature Microbiology, represents the most comprehensive investigation of its kind. The researchers didn't just test a handful of chemicals. They systematically screened over 1,000 different chemical contaminants against living gut bacteria in the laboratory. This approach gave them an unprecedented view of how the chemical world around us might be interacting with the bacterial world inside us. The Cambridge researchers tested 1,076 different chemical contaminants on 22 species of gut bacteria under controlled laboratory conditions. This wasn't a small pilot study. With over 1,000 chemicals tested, it provides the most detailed picture we've ever had of how environmental contaminants affect gut bacteria. The results were striking. The study identified 588 inhibitory interactions involving 168 different chemicals. The majority of these chemicals were not previously known to have any antibacterial properties. They weren't designed to kill bacteria, but they do it anyway. Let that sink in. 168 common chemicals, many found in everyday products, can damage the beneficial bacteria your body depends on. Which categories of chemicals showed the most concerning effects? Fungicides and industrial chemicals topped the list with the largest impact on gut bacteria. According to the research, around 30% of fungicides and industrial chemicals exhibited anti-gut bacterial properties in laboratory testing. Fungicides are widely used in agriculture to protect crops from fungal diseases. They're common on fruits, vegetables, and grains that make up a healthy diet. Industrial chemicals include compounds used in manufacturing, flame retardants in furniture and electronics, and plasticizers found in food packaging. But the study found concerning effects across multiple chemical categories. not just fungicides. Pesticides, herbicides, and various industrial compounds all showed activity against gut bacteria. The researchers noted that different bacteria showed different vulnerabilities. Some species were more sensitive to certain chemical categories than others. This matters because your gut microbiome isn't just one type of bacteria. It's a diverse ecosystem where different species play different roles. If certain chemicals selectively harm some species while leaving others unaffected, the balance of your microbiome could shift in unhealthy directions. Perhaps the most alarming finding relates to antibiotic resistance. When gut bacteria are exposed to these chemicals, some change how they function to survive. In certain cases, this adaptation also makes bacteria resistant to clinical antibiotics like ciprofloxacin, a commonly prescribed antibiotic for infections. The research team warned that if similar changes occur inside the human body, infections could become more difficult to treat with standard antibiotics. This adds a new dimension to the antibiotic resistance crisis. It's not just overuse of antibiotics driving resistance. Environmental chemical exposure may be contributing too. An important caveat. This study was conducted in laboratory conditions on isolated bacteria, not inside living humans. Inside your body, factors like the gut lining, protective mucus, and other bacteria might affect how chemicals interact with your microbiome. The actual exposure levels reaching bacteria inside your gut may differ from the concentrations used in laboratory experiments. Scientists urge caution about extrapolating lab findings directly to real-world health effects. More research in living organisms will be needed to confirm these patterns. That said, the scale and systematic nature of this research makes it difficult to ignore. 168 chemicals showing effects is a significant finding worth taking seriously. The study builds on a growing body of research suggesting that gut microbiome disruption is linked to multiple health conditions beyond just digestive problems. Research has associated microbiome imbalances with obesity, weakened immune function, and effects on mental health, including anxiety and depression. While we can't claim direct causation from this single study, the potential for widespread low-level chemical exposure to affect health through the microbiome is a concern worth addressing. The good news is that the study researchers themselves offered practical guidance on reducing exposure to the most concerning chemical categories. First and most simply, wash your fruits and vegetables thoroughly before eating. This was specifically recommended by the Cambridge research team to reduce pesticide residue. Rinsing alone won't remove all residues, but studies show it can significantly reduce surface contamination from many common agricultural chemicals. For produce likely to have higher pesticide residues, consider choosing organic when possible. The Environmental Working Group's Dirty Dozen list highlights the most affected items. Strawberries, spinach, kale, grapes, and apples typically top the list for conventional pesticide residues. Prioritizing organic versions of these may help reduce exposure. Consider avoiding pesticides in your own home and garden when possible. There are often natural pest control alternatives that don't involve synthetic chemicals. For indoor pest control, physical barriers, traps, and proper food storage often work as well as chemical sprays while avoiding potential microbiome effects. Water quality matters too. Consider using a filter system that removes chemical contaminants, especially if you rely on well water or live in an agricultural area. Look for filters certified to remove pesticides and industrial chemicals. Activated carbon filters are effective for many common contaminants and relatively affordable. Beyond reducing exposure, you can actively support your microbiome through diet. Fiber-rich foods, fermented foods, and diverse plant intake help maintain bacterial diversity. Fermented foods like yogurt, kefir, kimchi, and sauerkraut introduce beneficial bacteria, while prebiotic fibers from vegetables feed the bacteria already living in your gut. Aim for variety in plant foods. Research suggests eating 30 different plant foods per week supports greater microbiome diversity compared to eating the same few vegetables repeatedly. Read labels on household products and reduce use of those containing known antimicrobial chemicals when not strictly necessary. Triclosan and similar antimicrobials were once common in soaps and cleaners. While many have been phased out, checking ingredient lists helps you make informed choices. The Cambridge researchers emphasized that their goal isn't to cause panic, but to highlight an overlooked factor in gut health that deserves more attention. Most of us can't completely eliminate chemical exposure in modern life, but understanding the potential risks empowers us to make informed decisions about reducing unnecessary exposure. It's also worth noting that the chemical and agricultural industries have disputed similar findings in the past, arguing that approved chemicals are safe at regulatory exposure limits. The debate about chemical safety is ongoing, and this study adds important data to the conversation without settling all questions definitively. What makes this research valuable is its scale and systematic approach. Testing over 1,000 chemicals provides a broader picture than previous studies examining just a handful of compounds. And the identification of antibiotic resistance development connected to chemical exposure opens a concerning new avenue for investigation. If you're concerned about your gut health, the foundational advice remains the same. Focus on a diverse, fiber-rich diet. Minimize ultra-processed foods. Get adequate sleep. Manage stress, which has its own significant effects on the microbiome. Exercise regularly, as physical activity is associated with greater bacterial diversity. Consider this research an additional factor to weigh, not a reason to overhaul your entire lifestyle. Small, sustainable changes compound over time. And as always, consult your doctor if you have specific concerns about your digestive health. They can help you understand your individual risk factors and appropriate interventions. To recap what we've covered today, Cambridge researchers tested over 1,000 chemicals on gut bacteria and found 168 that showed harmful effects. Fungicides and industrial chemicals showed the largest impact. Some chemical exposure may even contribute to antibiotic resistance in gut bacteria. The practical steps are straightforward. Wash produce. Choose organic when practical. Filter your water. And support your microbiome through diverse plant foods and fermented foods. This content is for informational purposes only and isn't a substitute for professional medical advice. Always consult your doctor before making significant changes to your health routine. Thanks for listening to Better Health Faster. If you found this helpful, share it with someone who cares about their gut health. We'll see you next time.